Hi guys! This is Chresilyn from grade 12 Newton, and I am here just to do another experiment regarding on this General Chemistry 2 subject. So stay back, relax, and enjoy the rest of the video. And for the introduction, water is natural solvent that we utilize in our daily lives. Yet, it occasionally acts strangely and shocks us. Then, we wanted to figure out why we keep seeing these incredible things about water. As you progress through this experiment, you will get a better understanding of why water forms a specific structure and how that structure influences its attributes. Water has distinct characteristics due to the creation of hydrogen bonds between water molecules. The importance of these many qualities for life on Earth cannot be overstated. The unique properties of water as a consequence of the hydrogen bond are: first, it has point and exists as a liquid at room temperature. The second one, it has high specific heat which requires large amount of heat before it vaporizes. The third, it is the only substance that contracts when cooled because it's more often structured in the solid form. The fourth, it is high heat evaporation. And the last one, it has a high surface tension. This causes a large drop in temperature during evaporation. So in this activity, you can learn and you can encounter the solvent properties of water, thermal properties of water, cohesion and adhesion, and the water density. So for the objectives, first, determine the different properties of water. Second, differentiate all of the properties of water. And the last is explain the molecular structure and the intermolecular forces in each molecules. So, let us all explore through the experiment. For the first experiment, we have the solvent properties of water. So in this, we will be having 3 glass, water, salt, baking soda, oil, and the stirring equipment. Fill the 3 glasses with the same amount of water. Now, put the salt into the first glass and stir it gently. On the other glass, pour out the baking soda and stir it as well. Pour the oil into the last glass and stir it gently. Now, after 5 minutes, observe what happened. What happened when you put the salt, baking soda, and oil in the water? When I put the salt into the water, it dissolved. On the other glass, when I put the baking soda, it also dissolved but has precipitate, while the oil does not dissolve on the water. What is the reaction that happened on the oil in the water? The reaction that happened on the oil in the water is hydrophobic reaction. So for the conclusion for the first experiment, as you can see from the experiment, the salt entirely dissolves in the water. It has to do with the ion-dipole interaction. Water's polarity allows it to dissolve many ionically bound compounds. Positive sodium ions bind negative chlorine ions to form salt or sodium chloride. Because the positive parts of water molecules attract negative chloride ions and the negative parts of water molecules attract positive sodium ions, water may dissolve salt. The solubility of the material refers to how much of it can dissolve in a liquid at a given temperature. So in baking soda, also known as sodium hydrogen carbonate, is a white powder that dissolves quickly in water to release a sodium and bicarbonate ions. These ions produce carbon dioxide gas and water when they come into contact with acids. This is likewise a polar molecule, and the dipole-dipole interaction is present. This solution precipitates sodium bicarbonate as a solid. So because the water molecules are polar, the oil does not dissolve in water. This indicates the molecule has a positive charge on one and a negative charge on other. This makes it possible for water molecules to join together. Non-polar molecules, on the other hand, are found on oil. Non-polar molecules will only combine with non-polar molecules. This explains why oil and water do not mix nicely. Their molecules can form bonds. This is also a presentation of hydrophobic reaction. For the experiment 2, we have thermal properties of water. In this experiment, we will be having water, candle, matchsticks, and 2 balloons. First balloon should be regular and the second balloon should be filled with water. So first, you need to light the candle. Place the regular balloon into the fire. Next, place another balloon that contains water into the fire. Now, notice what happened. What happened when you place the 2 balloons into the fire? The first balloon that has only air inside was exploded, while the other balloon that has water inside does not explode. Instead, it has only black soot appeared. So why do you think this happened to the balloon with water? The balloon having water inside does not explode because water has a hydrogen bond. The water has also a high heat capacity. So for the conclusion in the second experiment, because water has a hydrogen bond, the balloon with only air will exploded, while the other with water did not. Water has a high heat capacity, which implies that breaking the hydrogen bond, having a reaction or impact on it, necessitates a high temperature. Experiment number 3, cohesion and adhesion. In this experiment, we will be having a glass, a dropper and a coin, food coloring, and water. Put water into the glass. Put some food coloring into the water. This is only to clearly visualize the water. This has no effect to the experiment. Using your dropper, put drops of water into the coin. Observe what happened. What will happen if you put droplets of water in a coin? The droplets of water stayed into place and bulging over the size of the coin. Why do you think this happened to the water in a coin? Cohesion holds the droplets together and adhesion holds the drops on the surface of the coin. The cohesive process is the pull of the water molecules on themselves. For the third experiment, the conclusion, the water on the coin stayed together and moved closer together as a result of the experiment. Gravity flattens the droplets, while cohesion keeps them together and adhesion keeps them on the coin's surface. The pull of the water is the cohesive force. Each subsequent drops adheres to the water on the coil already. Surface tension is how we refer on this cohesive force. For the experiment number 4, we have water density. In this, we will be having 4 cups with the same sizes, 2 food colorings, hot water and cold water, and plastic films. On the first set, put cold water and put a blue food coloring on it. On the second glass, put hot water and red food coloring on it. Place the cold water into the top of the hot water. Observe what happened. Now, repeat the first process. At this time, put the hot water into the top of the cold water. Observe what happened. What happened when you put the cold water into the top of hot water? When I put the cold water into the top of hot water, they mix together. What happened when you put the hot water into the top of cold water? When you put hot water into the top of cold water, they do not mix together. The hot water stayed into place as well as the cold water. For the last experiment, the conclusion is, we can see that when I put the cold water into the top of hot water, they mix together. This is because cold water is denser and it will sink in a room temperature. While on the other side, when you put hot water into the top of cold water, they do not mix together. The hot water stayed into place as well as the cold water. This is because hot water is less dense and it will float in a room temperature. And that would be all. Thank you everyone for listening. Keep safe, God bless, mabuhay, padayon, and keep peace everyone!